Okay, now number 7. Dilute hydrochloric acid reacts with sodium carbonate. Acid reacts with carbonate, salt, carbon dioxide plus water. Now a student do titration 20 centimeter cube of 0.02 mole per dm cube aqueous sodium carbonate with dilute hydrochloric acid using methyl orange indicator. Sodium carbonate volume is given and concentration is given. A volume of 15.5 centimeter cube of dilute hydrochloric acid react exactly with 0.02 mole per dm cube aqueous sodium carbonate. Hydrochloric acid volume is given 15.5 centimeter cube. You are asking calculate the concentration in mole per dm cube of dilute hydrochloric acid. So as sodium carbonate volume and concentration is given, so you can calculate moles of sodium carbonate concentration times volume. 20 centimeter cube divided by 1000, it has been converted to dm cube. This is mole, 5 times 10 to the minus 4, or you can write 0.0005 mole. And sodium carbonate 1 mole, hydrochloric acid 2 mole. So sodium carbonate ratio hydrochloric acid 1:2. I mean hydrochloric acid is mole is the double of sodium carbonate. So moles of hydrochloric acid, moles of sodium carbonate times 2. You get this value 1 times 10 to the minus 3, or you can write here 0.001 mole. Now concentration of hydrochloric acid, you know, N equals CV. C means concentration equal number of mole divided by V means volume. So number of mole 0.001, volume is given here 50.5 centimeter cube divided by 1000. It has been converted to dm cube. So this is the answer. .0645 mole per dm cube is the concentration of dilute hydrochloric acid. 0.0645 mole per dm cube. B1, state the color of methyl orange in indicator. You know, methyl orange in alkali, this is yellow, acid red, neutralization orange. So as it is alkaline solution, so this color will be yellow, acid red, neutralization orange. Two, write the formula of the ion present in aqueous solution of alkali. Alkali hydroxide ion OS minus ion is produced in a alkali. Number C, calculate the volume measured at RTP room temperature and pressure of carbon dioxide produced in centimeter cube when 2.65 gram of sodium carbonate reacts with excess hydrochloric acid. So you are asking volume of carbon dioxide, you will measure, calculate, but in question given 2.65 gram of sodium carbonate. Sodium carbonate mass is given, so you can use solid formula to calculate moles of sodium carbonate. Okay, first of all, moles of sodium carbonate mass divided by sodium carbonate molar mass 106. How you get 106? So this is the MR, relative molecular mass of sodium carbonate. 2 sodium 23 times 2, 1 carbon 12, oxygen 3 16 times 3, total you get molar mass 106. So moles of sodium carbonate mass divided by molar mass 0.025 mole, and you see moles of sodium carbonate and moles of carbon dioxide equal, I mean 1:1. So moles of sodium carbonate will be same as moles of carbon dioxide. So moles of carbon dioxide will be same 0.025 mole. Now volume of carbon dioxide, number of mole times molar volume. Molar volume 24,000 centimeter cube or 24 dm cube. But here question is asking you to find out the moles in centimeter cube. That's why volume of carbon dioxide, number of mole of carbon dioxide into molar volume times molar volume. You get 600 centimeter cube. This is the answer. Now the hydrochloric acid. Hydrochloric acid is a strong acid. Define the term strong in the phase strong acid. You know strong, completely ionized in aqueous solution. Strong acid means the acid which is completely ionized in aqueous solution. A strong acid completely ionizes in aqueous solution. E. Oxides of nitrogen contribute to acid rain. 1. State one other adverse effect of oxide of nitrogen. Photochemical smoke. Nitrogen oxide reacts with unburned hydrocarbon to produce photochemical smoke, or you can write respiratory problems. You get also mark. Now 2. Oxides of nitrogen are removed from car exhaust by catalytic converter. Complete the symbol equation for the removal of for the reaction that occur in a catalytic converter. Catalytic converter, carbon monoxide is a harmful gas, nitrogen monoxide is a harmful gas. Catalytic converter reacts to harmful gas, convert nitrogen and carbon dioxide. They convert more harmful gas to less harmful gas or non-harmful gas. Carbon monoxide reacts with nitrogen 2 oxide or nitrogen monoxide to produce nitrogen and carbon dioxide. Okay, now next. The equation number 8, the equation between carbon monoxide and hydrogen at a temperature in a closed container. This forward reaction is exothermic reaction. Delta H is negative. This is an exothermic reaction. So predict and explain the effect, if any, on the position of equilibrium when the pressure is increased and the temperature remain constant. What will be the effect on the position of equilibrium if the pressure is increased? So left hand side 1 mole, 2 mole, 3 moles, right hand side 1 mole. Pressure is increased, so equilibrium will go to left to right. Position of equilibrium moves to the right, I mean left to right, as there are fewer moles of gas on the right hand side of the equation. There are less number of there are less number of gas molecules or moles on right hand side. Now predict and explain the effect, if any, on the position of equilibrium when the temperature is increased. Temperature is increased and pressure constant. This reaction is exothermic. Delta H is negative. So as temperature is increased, it will go to the endothermic direction, I mean right to left, to the left. Position of equilibrium moves to the left, I mean right to left, because the forward reaction is exothermic reaction. So if you increase temperature, equilibrium will move to the endothermic direction to absorb heat or to reduce temperature. That's why increasing temperature, equilibrium will move to the left, because forward reaction is exothermic reaction, or you can write reverse reaction is endothermic reaction. Now B, methanol reacts with ethanoic acid to produce an ester. Name the ester and draw the displayed formula. Methanol CH3OH, methanol, this is the alcohol part, and ethanoic acid, this alcohol will lost OH group, acid will lost only hydrogen, so water will be produced, and ester will be methyl ethanoate. This part is acid part, this is alcohol part. Methyl come from methanol and ethanoate come from ethanoic acid, so ester name will be methyl ethanoate. This is the displayed formula. Displayed formula means you will show all bonds present in molecule. Displayed formula. Now methanol is a member of alcohol homologous series. Describe two general characteristics of a homologous series. You can write have the same general formula, and homologous series have same general formula and same functional group. You can write have same general formula, same functional group, or you can write differ from one member to another by a CH2 group, or neighboring member are different by a CH2 group. One is differ means different, one is different from the next by a CH2 group, and or you can write trend in physical properties, or you can write similar chemical properties. These are the characteristics of homologous series. Now number 9, this table shows melting point and relative electrical conductivities of three elements: calcium, carbon and iodine. So you see melting point calcium 834, diamond carbon is very high 3550, iodine very low melting point, and thermal electrical conductivity calcium is good as it is metal, diamond poor, there is no free electron, and iodine is poor, this have no free electron. Now you are asking use ideas about structure and bonding to explain the differences in the melting point of diamond and iodine. You have to explain differences. This is the diamond and this is the iodine. You see diamond has high melting point than iodine. Diamond has a high melting point because it is a giant structure of covalent bonds. Diamond is a giant covalent structure. There are a strong bond between all the atoms. Diamond is a giant covalent structure. There are strong covalent bonds between all the atoms. That's why diamond has high melting point, melting temperature. But iodine has a low melting point. You see, iodine only 140 degrees centigrade boiling point. Why low? Because there are weak forces between the molecules. In iodine molecules, there are weak forces between, there are weak intermolecular forces, or you can write there are weak van der Waals forces between molecules. That's why iodine has low melting point. Number 2, the differences in the electrical conductivities of calcium and iodine. You see, calcium is a good conductor, but iodine is a poor conductor. Diamond also poor conductor. Now you see, calcium is a good conductor. Why? Calcium has mobile electrons. Calcium has free electrons. That's why calcium is a metal. Metal has free electrons. That's why these are good conductor. And iodine is a non-metal. It has no mobile electron, or it has each electron are in fixed. There is no free electrons. Now B, diamond and graphite are different forms of carbon. Explain in terms of its structure why graphite is a lubricant. Graphite is a lubricant, and you know, in graphite atoms are arranged in layers. In graphite the atoms are arranged in layers. There are layers of atoms in graphite, so these layers can slide over each other. Graphite is a layers of atoms, so the layers can slide over each other, so that's why graphite can be used as a lubricant. Now a compound of sodium, iodine and oxygen contains 11.62% sodium, 64.14% iodine and 24.24% oxygen by mass. Deduce the empirical formula of this compound. So at first you write sodium, iodine, oxygen. Their percentage 11.62, 64.14, 24.24. First you will do divided by their AR. AR means relative atomic mass. So sodium 23. This value you will get from periodic table. Sodium relative atomic mass 23 and iodine 127, oxygen 16. First you will divide their percentage by mass by their relative atomic mass. You will get this value, this and this. After that you will divide by the smallest one. These three values, 0.50 is the smallest. So if you divide by all values by smallest one, you will get this 1. How? 0.505 divided by 0.505, you will get 1. This also 1. This 3. 1.515 divided by 0.050, you get 3. I mean here sodium 1 atom, sodium is 1 atom, iodine 1 atom, oxygen 3 atom. So this empirical formula will be NaIO3, NaIO3, sodium iodate.